This is what building a home on Mars might look like. This structure is being 3D printed by a robot and could one day be the solution to housing on the red planet. Now, a trip to Mars, let alone a home there, is still a long ways off. But AI SpaceFactory, the company behind the 3D printing system, thinks this unusual design and construction method could be used to make more sustainable Earthbound structures too. AI SpaceFactory calls them Terra, and the first is set to open early next year. It already has a waiting list to stay the night. To learn more about this futuristic interplanetary building system, we spoke with AI SpaceFactory CEO and architect.
I'm David Mallot. I'm the co-founder and CEO of AI SpaceFactory.
Recently, you've been doing work around 3D printing both for a Martian landscape and here on Earth. Can you talk about some of the technology that's involved in that?
Building in space is extremely expensive, and it's the launching of materials into space that really costs a lot of money. So our specific solution was to look at habitat on Mars, which could be 3D printed from materials that you find on the Martian surface. So you're not having to launch materials from Earth.
Are we talking about the same 3D printers that people use to make like plastic paperweights?
Technology-wise, it's not entirely different from the desktop 3D printer because we're still printing with similar materials, actually. It's just scaled up, and it has to be mobile and deployable and obviously operate in extreme environments.
So part of the challenge here with the NASA competition was trying to make use of materials on Mars and this new technology that can turn that into a feasible structure. What were some of the other parameters of that challenge?
The system needs to be totally autonomous. When we think about wanting to send astronauts to Mars, they get there, they kind of need a place to stay once they arrive, which means that the infrastructure needs to be built out in advance of human arrival. So 3D printing was one solution, but to do it completely autonomously so that the rover could go in advance, basically build a house so that when the astronaut crew arrives, a habitat and all the other infrastructure that you need is already there.
Can you describe what these structures look like?
In terms of color, I think definitely they will have a Martian hue because the actual material is the Martian rock. We have a piece of simulated Martian matter. So obviously this is not from Mars, but it's 3D printed from the materials that we would expect to find on Mars. The Terra, we're definitely printing it larger than the prototype we made for NASA. So it's 21-foot diameter, 24 feet tall. Two-story home, so 500 square feet. It falls definitely in the tiny home category. The Martian habitat we designed was about double that size. So it's 1,000 square feet. Now the design itself is quite unique, and if you can take a look, it has this egg shape. This is to optimize for the structural forces that we anticipate on the structure. Maybe our previous imagination of what buildings on Mars might look like is more like a dome or something that's low-lying. We found that it was actually more efficient to build vertically. Its shape is, if I can draw an analogy to a Coca-Cola can, because the fundamental force that's acting on this is the inside pressure is much higher than the outside Martian atmosphere, which is very thin, and so it tends to want to expand. So this shape is just very, very efficient at containing that internal atmosphere.
How exactly does the 3D printer work when it's building a structure?
It prints it layer by layer. I think the easiest way to describe it is it comes out looking like toothpaste. It just sort of squirts out a nozzle. As it cools down, it sets and it becomes extremely hard, but it comes out kind of like in this molten form. So the interesting thing is we don't need blueprints like in the traditional sense of architecture. We can go straight from a digital model, and we have a process that converts the 3D model into a language that the robot understands.
What have we learned about 3D printing houses from this experiment? It seems like building something similar on Earth might be easier.
You would think so, and we're going through that process right now. So after we designed Martia and built a prototype for NASA, we began a project we call Terra. So if you think about the whole concept of 3D printing on Mars with Mars material, apply that to Earth, it's a much more sustainable way of building, to be able to send a robot out to a site, gather the materials that are there. So that's where the space technology really has applications to Earth. Now, on Earth, we have to deal with problems like rain and snow and things that we're not going to find off-world, which frankly we're having to go through right now as we build our first Terra.
Unique challenges on Earth.
Yes. So now we have 3D printing. We have the ability to print with natural materials. We're not restrained by form anymore. As we're developing the technology, we're sort of rethinking the design as well. So the buildings that will emerge from this process will look nothing like the buildings that we've seen so far.
How long does it take to build one of these structures for Mars or for Earth?
Yeah, so on Earth, I know that answer a little bit more clearly. So like, Terra, if we were to sort of print it around the clock, we'd be looking at something like 200 hours. When you're talking about a Martian environment, I think it's a lot different because just the amount of time that it would take to sort of collect the materials, right? So it could be a far longer process because you have more extreme temperature swings. I think you also run into considerations there. So I can't fathom a guess, but if I were to throw out a number, it'd be in the order of months. So it's not a super fast, instantaneous process. The part of the technology that's the least understood at the moment is the sort of harvesting of the natural materials, and then how do you process these things on site. And so right now a lot of these steps are done in the lab or the factory environment, and what we're going to be doing next year is taking the material aspect of what we're doing and moving it out into the field.
So on Mars, you're harvesting materials from the planet itself. How exactly do you turn that into something that's a feasible building material?
It's like pasta. If you've ever made pasta at home, you kind of put the ingredients in one end and you turn a crank and it sort of comes out through a die, right? So you make this long strand of spaghetti from the raw ingredients. It is about raw ingredients. How do you mix them? What temperatures do you cook them at? That's sort of really what 3D printing is like, actually. It's about your raw ingredients. It's about your temperature. It's about your timing. We're like harvesters and scavengers. It's just like taking what's there, scavenging the waste. Can you cannibalize the lander itself and extract the materials from that? And then you sort of take this line of thinking and pull it back to Earth, and you say, well, what are the natural resources on Earth that we can use? And yes, there's like the rocks on Earth and the plants on Earth, but we also have a lot of garbage on Earth. So when you talk about what is your potential building material, and it's going to be waste, and there's no reason why we can't 3D print from plastic waste. So Terra will actually be about 50% recycled plastic waste and then 50% biopolymer.
We're talking about robots that are big enough to build an entire house. Are you developing these robots yourself? Like, what do they look like? How do they work?
Our strategy is not to build like a giant robot, but to take a lot of robotic systems and put them together. And so our main 3D printing robot is a typical industrial robot that would normally build a car. And we're connecting it with other elements that move. For example, when we're printing the Terra, we're printing it on a turntable. So we're spinning the print like a potter's wheel. And then we put the robot on a forklift so that it can reach up to 24 feet high. You're not having to talk about giant machinery. You can actually talk about modest machines, but as long as they're given a kind of mobility solution, then they can begin to reach all parts of the building. So that's why I think that there's no theoretical limit in terms of how tall or how large or how many you can build.
I'm sort of reminded of the hype around 3D printers themselves 10 years ago, when everyone sort of thought you'd have these things in your home and you would be able to print anything you wanted. And of course, that hasn't really panned out. Why do you think 3D printed architecture is different?
We have over 300 people signed up to stay in the Terra over like 400 nights. And because of the success of that, we're already talking with our one of our customers, let's call them, or our future Terrans. They want to build their own. I think the interesting part about it is the people that we're talking to they bring their own views to the table, but everyone is sort of like linked together by this greater mission about wanting to find more sustainable ways of living and building on this planet. So I think it'd be quite interesting to see how this evolves over the course of the next couple of years.
So believe the hype, but give it time to mature.
Exactly. So see this in the long term. We're in a business that when you talk about space, it's extremely long-term horizons. And 3D printed buildings is something shorter than the space horizon, but nonetheless, it's going to take time until this is really like cost competitive and as scalable as traditional construction. But that shouldn't limit us from starting this, because if we don't start it now, there's simply no way that we can build enough buildings for growing populations and rapid urbanization and do it in a sustainable way. So we need this new technology. It's an absolute must.
Thank you so much for joining us.
Thank you. It's been my pleasure.